Hello everyone, my name is Marianne Pedinotti and I'm a PhD student in the University of Sherbrooke. Today I will present my paper that is called Freight Transport Modal Shift in a Times Energy Model, Impact of Endogenous and Exogenous Modeling Choice. So this paper has been published in October 2022 in the journal Applied Energy. This paper is written in a context where the freight transportation sector represented 16% of Quebec greenhouse gas emission in 2019. In a context where the world and Quebec wants to reduce their GHG emission, we have no choice but to decarbonize this sector. For now, what solution do we have to decarbonize the freight transportation sector? So we have electric battery trucks that are currently developed. We also have catenaries trucks that are considered for 2030. And we could have electric trains, but trains are not so much considered as most of the freight products are transported by trucks in Quebec. So as you can see, we foresee only technological solutions. So what about behavioral solution? Because we can hear talking about behavior changes in other sectors, for example, in the private transportation sector. So why not in the freight transportation sector? In the freight transportation sector, behavioral change can take the form of a modal shift. So this is the objective of this paper. What about a modal shift between heavy trucks and train? To do that, we integrated the possibility of modal shift in a very technical model, the North American Times Energy Model, NATEM. NATEM is a huge optimization model that represents the whole energy system in Quebec. So we adopted two modeling strategies to integrate modal shift in NATEM. The first one is the exogenous technique. Exogenous means that the modal shift between heavy trucks and train is based on external hypotheses and entered as an exogenous variable in the model. For example, the modal shift is fixed following the hypothesis that if 17% of the good can be transported by train, then we can reduce the truck demand by 24% and we can increase the train demand by 6%. The second modeling technique is the endogenous technique. Endogenous means that the model can choose by itself and optimize whether to shift the demand or not between heavy trucks and train. It is done by integrating the elasticities of substitution in the model. So what we did in this paper is we compared scenario of modal shift with the two modeling techniques. And spoiler, all the results are different. For example, the demand is different. So as you can see, if you let the model choose by itself on the right, it does not switch as much the truck's demand as if the shift is fixed on the left. The energy consumption is also different. The exogenous modeling technique permits to avoid investing in advanced technologies such as catenary, even in 2050. And finally, the costs are different, as the exogenous technique permits to avoid several $1 million per year. So basically, the takeaway messages of this paper are threefold. Firstly, it is clear that in a decarbonization context where the models are already super constrained, the modeling choice is crucial. Secondly, models are not constructed to model decarbonization scenarios that are radical scenarios. And finally, integrating model shift into technical models can help reach decarbonization solution. I hope you liked my presentation. I will invite you to learn more about our work in LIRID at this address. You can also read the complete paper by looking for this info. And finally, do not forget to like this video and subscribe to the LIRID channel right here. Thank you all for your attention and see you next time.